Thanks for dropping in to another iteration of the Sketchy Tactics Weekly Development Update. As always, this is coming out in advance for supporters and will be available a week behind for everyone else. It is Memorial Day. Did a lot of stuff this weekend. I'm very tired, so gonna kind of breeze through this. But we got a lot of stuff done over the Memorial Day weekend. I was working on implementing line of sight requirements in for the spells. So some enemies can use actions and some players can use actions that don't require line of sight. An example would be if you were yelling at someone, you don't have to be able to see them for them to hear you. But if you were, for example, shooting an arrow or something like that, you can't shoot it through a tree or a wall. So basically adding in checking for obstructions depending on how the spell is flagged. And the player part of that was easy, and then I started working on the enemy AI and realized that it was getting very, very complicated. There was far too much code, and I was having to write code for essentially every combination of conditions that could occur, because at that point it was kind of a finite state machine. And so I realized that I was going to have a growing problem in that not only were the enemy behaviors too simple, but maintaining it was getting very, very complicated. So I did a little bit of research into alternate approaches. All of this enemy AI is new. I haven't worked with this before. So as I said, there wasn't really an AI requirement in the first game that I did. So I did a little bit of research, and I came across something called GOAP, Goal-Oriented Action Planner. And I'll put in the show notes a link to the code repository that I sort of examined to learn how the Goal-Oriented Action Planner works. But long story short, that was pretty much exactly what I was looking for. So I spent a bunch of time kind of diving into how it works, how it ties together, etc. And it was absolutely brilliant, except that the implementation wouldn't really work for the game type that I had. So I couldn't replicate it exactly. It was really designed for like action games, RTS, things where activity occurs essentially in real time, whereas we're turn-based, and everything in it was also based on free movement, and we are grid-based with different kinds of constraints. So basically, I couldn't implement the framework as is, but I liked the approach, which is giving the enemies goals with different values, indicating which things further those goals, and scoring them according to different criteria, and then having them essentially make every plan they possibly can, and then just execute the one with the highest score. So that's the making an action plan that is to further some goal that they have. Super high level. So what I thought I would do for this demo is I'll do a little bit of poking around with enemies here. I cheated and I'm loading into a more complicated area here. Let's do, this has the most diversity. So just to show you, and this is one of the unconfigured maps yet, so two of the enemies are going to start on top of each other, but that's not a bug. That's just I haven't set up the start positions here. There they go. They've separated. So you can actually see in the debug log here, I'm spitting out all the different plans they made. So there's different scores, and I'll kind of get into how the scoring and stuff works. But this jumper enemy, and I'm not sure which one it is because they all have the same art now, but this jumper enemy, they're going to highly, in the absence of the ability to kill or damage a player, they're going to highly prioritize essentially tanking or getting closer to the player. So it's going to use the jump ability and get closer. Support's going to move around. Now the support would do healing, except that there's no one to heal. So we're going to step in here and damage someone. And depending on cooldowns and various things like that, they won't always heal. So now this one's close. He's attacked me. So in this case, the enemy actually prioritized debuffing me over healing because of its profile. And I don't have enough AP, but you get the gist of it. So it used up enough AP that it couldn't heal because of the debuff. So presumably this turn it would try to get in range of one of its compatriots for the purpose of eventually healing it. Let's see if we can make that happen. Actually, I don't think it has enough range on its ability, but basically you get the idea. Now, the good news is that, as you can see here, let's see here. It's probably going to debuff me and run away again. Yeah. Anyway, you get the idea. All of this looks basically the same as it was before. They're kind of behaving the way they would have behaved previously. There's actually a little bit more range of behavior right now, but the implementation of this is much more complex, has a lot more capability, and actually kind of has less code in some ways. So what I thought I would do for this video real quick is basically just run you through at a high level from a source code perspective and a resource perspective how the implementation works. So I'm going to switch over to code here, and we're going to start with the goals. So we've implemented a set of basic goals right now, and these mirror the range of capabilities in the original finite state machine. So every individual enemy is going to have a set of goals, and they're going to put a type on that goal and a value on that goal. And then later on, we're going to basically be asking, when we go to do things, which of these actions further one of these goals. So for example, if I have a spell with a damage effect on it, that furthers the damage player goal. And so if my enemy has a goal of damaging player, it is going to try to use that spell to accomplish that goal. So this is basically just a mapping, right? So if we want to damage a player, we want to use damage. If we want to heal an ally, we want to use healing. These are our debuffs. These are our buffs. And for tanking and kiting, and this is where it's nice and gets flexible. Previously, the move and teleport abilities were only usable by the enemies, because that's how the state machine was coded, to close the distance to an enemy. But now, because of the way the action planner works, I've slapped that on tank and kite. So the enemies will actually use any movement or teleport abilities they have to both close the distance or run away, depending on what scores the highest under the circumstances. So this part is already more powerful than it was before. So that's how the goals work and how the different types of abilities map to this. And the idea is that you may actually have a spell that does damage and takes AP. And in that case, it can be used to further either of these goals. So depending on which the enemy values under a given circumstances, it may use the same ability for multiple reasons. But right now, all the abilities just have one effect because I haven't gotten around to wiring that up. So that's kind of how the goals work. And if you want to see an example here, if we look at our jumper, the jumper has 3 goals. One is to damage the player, and that's its highest value. The other is to tank. That's a slightly lower value. And then the last one is kite, which has a negative value. So unless other circumstances modify it, the jumper is never going to move away from players. It's always going to be moving towards players and trying to close the distance, be next to them, use its melee attacks. And these numbers there's nothing particularly magic about them, but they just interact with different ranges of values that I chose. So that's how this shows up in Unity on our different enemy types. The next thing that we had to do was create the planner. And so we previously had a take a turn, which was this huge long finite state machine that figured out, based on all the conditions available, what was the best thing to do. So we completely replaced take a turn with this small amount of code. This is really it here. And this basically just says we're gonna loop forever, sort of, and we're gonna get all the action plans that score above 0. So if you remember our -100, that means unless something else modifies the score, we're never going to choose that one. And then if we come up with more than 0 plans, so any amount of plans other than 0, we are going to get the one with the highest score, and we're going to enact that plan. And then this is just a debug thing that I wrote that prints out all the steps in the plan and the score, so I can keep an eye on whether or not it's doing what I was kind of hoping it was doing. That just looks like this. It's just a debug. Now, because the individual steps are actually just function delegates that get acted on later, what I do is I actually have in the, where's the action plan class? I actually have debug steps. So every time I add a step, I also add a string of information about the step. And they always go on at the same time, so I can pop both off the queue and print out the details. So that's just a little debugging tip. So all the magic here is get action plans and enact plan. So let's see what get action plans does. First thing we're going to do, set up our list. This is something that I decided on, which is essentially any enemy that is capable of killing a player, meaning it has any ability to do damage, will first check to see, well, and the order doesn't really matter, but it will basically always check to see, based on the estimated damage that it can deal, whether or not it thinks it might be able to kill a player. So that is not wired into the enemy. Every enemy tries to do that. If I want an enemy to not be able to do that, all I have to do is not give them any damage abilities. So this will always happen, and we're basically going through all of the actions we can take, and I'll get to fight actions in a bit. This fight actions replaced our enemy spells. So basically I'm going to go through those, find any of them that have a damage ability, and I'm going to order them descending by their action point cost. I actually don't think this matters because we're going to go through all of them and it's just going to pick the highest score. But I think because the score is always going to be the same, it actually prefers to use the lowest if it can. But again, I'm not actually sure that this does anything. This was the first thing that I wrote, and I've sort of figured out more about this, so I may take that out. Right now we don't have crits implemented. So the first thing that we do is estimate the damage. So we're basically saying here's the action, and we're passing in the enemy so we can get its stats, and the possible target so we can get its stats, and estimating the damage. If the damage estimate, which is right now basically, it's not accounting for crit, so it just figures if the spell rolls average. So the enemy can think it can kill the player and be wrong. It can also think it can't kill the player, and it could have. So we don't want everybody to be perfectly smart, so that's actually fine. It's more fun if the game is more fun if the enemies sometimes make mistakes, the same way we, the players, do. So we're going to create an action plan. We are going to score it just under 10 million, arbitrary number, but nothing is remotely capable of getting that high. And so if we think we can kill a player, that's basically always going to win. And then we're going to resolve movement. And the way the resolvers work, I'm not going to go through all of them. But the resolvers basically, the first thing they do is check to see if they can perform the action from where they are without moving, because that saves us a bunch of calculations if we don't need to do them. So if it has infinite range, or we're in range, or it is not a ranged ability but we're right next to them, then we're just going to do that. And what it does is it takes the action's perform ability, which I'll get into that, and it puts it in the step queue for the plan. So when we actually make a plan to do this, it could have multiple steps. As I said, for example, we might have to move first in order to use the ability. So that would be 2 steps, basically. Move, then use the ability. So we're queuing up our steps, and we're queuing up our debug string. And then we are actually increasing the score by the amount of moves remaining. So in this case, let's say we're doing a damage player, and the damage player move. Let's say there's two players that I could damage. One I'm standing next to, and one's further away. And let's say I would do the same amount of damage to both. I actually want to prefer attacking the one next to me because it's more efficient, because I don't have to use movement first to attack it. So that gives me the option to attack it and then do something else, which means we want to slightly favor that plan versus the other one. So we actually make the score of the plan higher by the leftover moves remaining. So if we had 3 targets and one took 1 movement, one took 2, and one took 3, the one that took 1 would have 2 points left over, and the score would be +2 versus +1 or +2 versus the others. So it would get favored. Now it could actually get overridden by some other more valuable plan, like, oh, we can kill that 4th player. But you get the idea. So essentially you make the enemies incentivized to do what they should do based on efficiency and outcomes by just manipulating the score of these plans. So here we're really weighting this, which is we always, if we can damage a player without moving, we always want them to try to do that first if they have a damage ability, and then go find other things to do. So even if it's an enemy that's going to run away, if it can hit the player and then run away, we want to do that. The only thing that trumps that is killing a player. So we jack the score up pretty high here. Then if we can't use it from where we are and we have to move first, the next thing we do is move. And there's basically 2 ways to do this. One is if it's a linear ability, meaning all I have to do to use it is be in line with the player, then we basically find a path that gets us in line with the player. Otherwise, we basically move as little as possible to get in range, which could include, angled attacks and stuff. And this is linear abilities are a sort of specific type of ability. So like pulling a player towards you is a linear ability because you can't pull them across squares that you can't move through and diagonals and all that kind of stuff. So then if we come up with a movement path, we check to see if we can use it from there, from where we are proposing moving to. And if so, we are going to stick in our steps to move and then to perform. And again, I'll get to perform shortly. And in this case, our score is, excuse me, our score is actually reduced by how much movement has to be performed. So again, if we can hit a target by moving 1 square instead of 2, we prefer to do that. And this shortened thing just has to do with a calculation that's used to make sure that, like, let's say the player is 4 spaces away. We could move 3, but our ability has 3 range. We use shorten to only move 1 to do the ability. So that's part of the score calculation. So this is basically economics. We're giving incentives for them to do what we think they should do. And a lot of times they're smarter than I am, as I said. So there's just different variants of them depending on whether we're going after a player, an enemy, or we're targeting a location on the grid. And then there's also a resolve movement only plan, which is very similar. But this is basically we have to make plans for what we would do using only our movement, because there are circumstances in which the enemies don't have things to do. And again, we can ignore all the conditionality of that. We just make every plan, right? So we make a bunch of plans to use our abilities. We make plans to just move and do nothing else. And those will naturally score lower than any abilities we could use for the most part. And so they just won't happen. So that's the idea. We just make essentially every reasonable plan, and then we do the one that scores the best. Enact plan is pretty simple. That's our thing that does it. Basically, while there are more steps in the queue, we say the player is busy, and this just prevents things from happening until they're done. We dequeue it, which means we take the next step in our plan off of the queue and we invoke it. which means we call that function, whether it's the move function or it's the perform for the action. So this basically anything that can be treated as an action, which is a built-in C# type, can be stuck on the queue and invoked later. So that's kind of function delegates or lambdas, very much like this. And then we basically wait until we're not busy anymore. So everything that we would dequeue and do will eventually set us back to not busy. And this is just to prevent things from all happening essentially at the same time, right? So we want them to move and then not do other stuff until they're done moving, just so they order their activities. So that's how an act plan works. And essentially everything else here are just targeting functions. So we have functions to get all the opponents, get everybody we can reach given an action, get all our allies we can reach given an action, just all kinds of different versions of this. The nice thing is there were way, way, way more of these in the old system, and I don't need most of them because all of the variations in logic they were doing are actually accounted for essentially by the scoring system. So that was really cool. And then these are some fun ones that are used to offset different types of scores. One is total distance from all players. So if our enemy is chickening out and running away, they're going to try to pick a space they can reach that's the furthest from the furthest overall from all the players still in the fight. These are opponents who can't reach us and can't see us. So if the enemies are being cowardly, they're going to prefer moving to a space that has a line of sight obstruction or is outside of the player's range. And we can prefer one or the other again by manipulating the scores. And then if they have any linear ability, we want them to slightly favor moving to a space that's in line with one or more players. So those are just things we use to adjust the scores to incentivize the right behavior. And then the rest of this all works the same as it did before. But as I said, there's just less code, which is great. That is absolutely great. So that is how the planner works. So it's basically just create all the plans, throw all the steps in queues, rank everything by score, pick the highest, pull the steps off the queue, and do them. That's I just made it sound way simpler than it actually is. Okay. So in all of that, other than the movement, which is just moving them, all of it is all about doing our fight actions. So I'm going to show you this abstract class fight action. We can't use this directly, but this is basically the contract that all of the valid fight actions, which again used to be spells, have to implement. So they have a display name, like punch. They have an action point cost. They have a maximum range. They all have a minimum range of 1, so that's a way to keep the enemies really simple. I may change that at some point, but right now we don't have to set max range because their min range is always 1. Math range, I think I've talked about that before. You can ignore that, but that's a special range type. They have an AoE size cooldown. They have a per target limit. They may or may not require line of sight, and it may or may not be possible to buff or debuff their range. And then these are all the effects that the spell has. So if you remember the effects, those are things like damage, healing, etc. And we have an accessor to get all these spell effects here, which is actually used, well, that's the internal state. I forget where the accessor is. It's in here somewhere. Yeah, right here. This is an accessor to get all the effects. And that's the thing that's actually used when we check to see if this fight action maps to one of our goals. So when an enemy gets created, we compile all the effects that this action has into a simple list and use that for comparison. Then we track our cooldowns and we track our already targeted this turn. So some abilities have a cooldown, means if you used it this turn, you have to wait X number of turns until you can use it again. Some have per target limits, which is like there's no cooldown on this, but if there's 2 players, I can use it on one and then the other, but I can't use it on one and then use it again. So that prevents them, if they have a low cost attractive spell to use, from just spamming it like 9 times on one player. And then a couple fixed properties. Does the spell affect players? So like, are we damaging a player? Does it affect enemies, meaning are we healing an ally? And then our require linear. So these are abstracts, meaning that each of the fight actions has to set them to true or false, but the abstract class has no preference. Various other things here. So that's just a couple accessors. So we have 3 variants for targeting players, enemies, and spaces again. For the is usable, that was used in our planner to say without movement or with movement, can we use this from the proposed location? And this is basically responsible for do we have enough action points? If we're targeting a player, does this ability actually work on players? If we have a cooldown, is it off cooldown? If we have a per target limit, have we not targeted this person yet? If it requires range, not everything does. Are they in range? If it requires line of sight, do they have line of sight? And if it's linear, are they actually in line with them? And if all of these conditions, if none of them return false, then yep, it's usable from this space. So there's 3 variants of that. These are virtuals because essentially every action can use them without modification, but we have the option in a fight action, if it does something totally funky, like it's usable from literally anywhere, it does the same thing every time, then we could just override is usable from space and just return true every single time. Then we have an abstract function called perform, and this is the thing that the planner puts on the queue, and this is what actually does the ability. So this gets called when the plan gets executed. So this doesn't have a default implementation because that wouldn't mean anything. And then we have to create a function that says whether or not it requires in range. And then they all have a do end of turn that's called at the enemy's end of turn that just fixes up the internal state by like decrementing cooldowns and clearing out the per target limits. So that's the gist of how a fight action works. Here is an implementation of one. So this is just essentially a generic attack. And I'll show how this works in the inspector in a bit. But we override our bools here. So we're saying that our generic attack can be used on players, it doesn't get used on enemies, and it's not a linear requirement. And then we write our perform function, which is just all the logic to actually do the thing. And so we do things like face the correct direction, check who we're hitting, get the damage, tell them that they're taking that much damage. If it has a per target limit, we put them in the limit bucket. If it has a cooldown, we put it on cooldown. We deduct the action points from the cost, and then when we're finally done, we say that the agent is not busy anymore so that it will proceed to take the next step in the plan. And this one requires them to be in range. Now, the nice thing about this is it's pleasantly generic, so we can actually have different abilities, different enemies have different variants of this with different names, ranges, costs, you name it. And as long as they're all just a single damage action, they can all use this class. So let's show an example of that. If we look at a tank, so we looked at their goals before. Now you can see their action. So we have a basic attack fight action on here. It's called headbutt. Its AP is 3, range 1, size 2, cooldown, per target limit. So all of these things are variables on the attack action. So if we wanted a different type of enemy to have a similar attack, but with different range, maybe a higher cost, does a bunch more damage, or even this enemy to have 2 attacks like that, a close range high damage and a long range low damage, we can slap multiple versions in here. The planner will consider all of them, and it will do the one that it thinks will deal the most damage given the circumstances. So if the enemy's far away, it would normally prefer to do the higher damage attack, but it can't because it's not close enough, so that will have a lower score. And that's pretty much how it works. So all the enemies now have variants of that. If we look at the headbutt on this enemy, has a different damage profile. We have a pull action, we have an attack action. Let's see, we have a push action, we have a debuff called webbing. So essentially we've implemented over here a bunch of different actions. This is our interface, and these are all of our different action types. And all the enemies have variants of those at the moment. And so if you want one to be fundamentally different, like a linear only ability, or to do something totally unusual, like swap positions with the player or something like that, we can create a new fight action, write different resolution logic, and we're good to go. So the nice thing about this now also is that you can play with different types of enemies and different behaviors by futzing with their goals and values, and slapping different abilities on them and seeing how they behave. And none of that requires writing any code. So essentially only need to write code when there's a totally new goal type to add, or a totally new type of ability to use. Now, ultimately, when we add in animations and things, we will, of course, have a play this animation when you do it, and we'll have to put a reference to that here as well. But right now, we're not doing that. So I think that's essentially an overview of the entire planner. I'm happy I pulled it off in one long weekend, and basically got it to the point where it's slightly more sophisticated than the prior system, but also way more expandable, as I said, easier to manipulate. I can change the behaviors of enemies without touching code, etc. So huge upgrade, great to build upon. It probably has bugs, flaws, and oddities I haven't discovered yet, and I'm sure that there will need to be additional goals, and there will be much more complicated fight actions as we get deeper into the game and create more challenging enemies. But it's a much better system to build upon. Learning how GOAP works has been super cool. It's really made me, the whole time I was working on it, I was thinking about, oh, this is how this enemy in Skyrim worked. This is how the moblins in Breath of the Wild worked. Now I have an idea of how I would do AI for like MOBAs, RTSs. I mean, really opened my eyes to how this aspect of game programming works, and I'm very excited to continue working with this, and I think it's going to make the game in the long run a whole lot more interesting and engaging from an enemy behavior perspective. It'll just look way cooler when they actually have art and animation. So, bit of a long video, but I wanted to walk you through how I conceptualized and implemented this turn-based grid combat variant of a goal-oriented action planner. Hit me up in the comments if you see any giant flaws, and I would definitely check out GOAP. As I said, I'll put a link to the repo, and you can find tons of articles and tutorials on it. But yeah, very cool. Just I love the ability of basically creating a currency and using monetary incentives to make the enemies behave in ways that we want them to behave. That just is very intellectually stimulating. So that's it for this week. Thanks for checking out the video. Again, if you're a supporter, you're getting this ahead of time. If you're not, it's on a delay. Something I mentioned before also is I am starting to think about looking for artists and then potentially writers or level designers to collaborate with at some point in the future. So if you or anyone you know would be potentially interested in working on this game, given its type and aesthetic, hit me up or put them in contact with me and we'll talk about it. And yeah, I hope you had a good Memorial Day weekend, and thanks for watching.